I have a little video tutorial for you. It's about calculating probability. When you have multiple events going on, how do you calculate the probability of a given combination of events? And we're gonna figure it out by answering these 6 questions. It's almost like the Bridge of Death in the Holy Grail, Monty Python's Holy Grail. That is a hilarious movie. He asks each traveler 5 questions, 3 questions, 3 questions. He who answers the 5 questions, 3 questions. The king keeps saying 5 questions every time and then getting corrected. And this troll asks these travelers 3 questions. And of course, the first 2 are like, "What is your name and what is your quest?" And then the third one's always something like totally random. "What is your favorite color?" Ooh, okay. And then the next guy, he gets on his third question, "What is the capital of Assyria?" "I don't know that." And he gets thrown to his death. It's terrible. But at the end, when the troll gets thrown by his own question, King asks him, "What do you mean? African or European swallow?" "Oh, I don't know that." And he's out of there. Anyway, don't panic. This is not a life or death situation. So anyway, we have a forecast. I'm really into weather, so I decided to throw a weather problem in here. We have pop, like soda pop. No, that's actually POP is probability of precipitation. And we're going to assume, since it's August, that it's going to be rain here. Now, if you're down in like southern Chile, closer to the South Pole, this time of year in August, it would be their winter, so it'd be cold down there. But we're going to assume that it's going to be rain. Probability of precipitation would be rain, snow, sleet. So anyway, on Monday, let's say we're looking at this on Sunday, and we see a forecast for 40% chance of rain on Monday, 30% on Tuesday, and 50% on Wednesday. Now we're going to assume that there's 2 possible outcomes. That's pretty apparent from looking at this. Either it rains or it doesn't. So there's a 40% chance of rain on Monday, which means that your cumulative probability always has to be 1. So to get to 1, you would just take 1 and subtract the 0.4, and you would get 0.6 or 60% chance that it will not rain on Monday. Tuesday, it would be 1 minus 0.3 would be 0.7 or 70% chance that it does not rain on Tuesday. And then Wednesday would be 1 minus 0.5 would be 0.5, so 50-50 on Wednesday. So what we're going to do is fill in this basically truth table, and we're not going to do this because students often will do stuff like this on a test. They'll like, "What is that? Is that a T or an F?" Well, I'm just going to say the whole test is a big fat F for trying to double dip there. No, I'm just kidding. Except I would actually mark that wrong, and so why not just write T or F so you have at least a 50-50 chance, because there's a 100% chance that you will get that wrong if you try to write both T and F. And it's like, yeah, I know what you're up to. I know you really don't know what you're doing, right? Okay, so anyway, there are 2 possible outcomes on Monday. Either it rains or it doesn't. And then there are 2 possible outcomes on Tuesday. So you multiply those together. So 2 times 2. So far we have 4 possible outcomes for Monday and Tuesday. Then when you add Wednesday in there, well, there are also 2 possible outcomes. So you multiply that by 2, and you get 8. You have 2 times 2 times 2, or 2 cubed. So you have 8 possible outcomes. And we're going to fill in this truth table. We're going to use Y for true, that it does rain, and N for no, that it's false, that it does not rain. Well, to fill in one of these, you start by breaking the first. You have 8 scenarios, and we're going to have 4 that it rains on Monday and 4 that it does not rain on Monday. So even though there's a higher probability of no rain, actually, we're going to write an equal number of yeses and nos. And we're going to apply this, whenever there's a yes, we're going to apply this 0.4 multiply. So we can already fill in this part of this table. That's going to be 0.4. There's a 0.4 probability of a yes on Monday that it rains. So 0.4 there, and then this is going to be 1 minus 0.4. It's going to be 0.6. I don't know if you can see the decimals, but that's a 0.6. And then on Tuesday, so on this one, you break it down and say yes, yes, no, no. So you do 2 yeses, 2 nos, and then or it would be T or F, or that thing that you can't figure out. It's totally ambiguous whether it's a T or an F. And then finally, for the third one, you alternate. So it would be yes, no. This way you cover every possible combination of events that could happen. So you 8 different probabilities, and the other thing we're going to do that's going to help us answer these, we're going to add together the number of yeses. So this would be the situation where it could rain all 3 days, even with the probability isn't going to be great, but we have 3 days, and we have 2 days with rain there. We have 2 days with rain there. We just have one here that it just rains Monday. That one, it's the other way around. There are 2. It doesn't rain Monday and rains Tuesday and Wednesday. There's one here, just rains on Tuesday. This is only it rains on Wednesday. And this is no rain on any of the 3 days. That's also possible. So 0. So the associated percentages with the yes over here on Tuesday, there's 30% chance it'll happen. Remember, I said these multiply together. So far we have 0.4 times 0.3. So that's going to be a 0.3, and then the odds of a no on Tuesday are going to be 0.7. So we're going to multiply that by that 0.4. And then we're going to do the same thing, fill in the 0.3s for the yeses. And for the no, it's going to be 1 minus 0.3, 0.7, just like we have up on, it'll be the same as what we have up here. And then we're going to have 0.5, and then 1 minus 0.5 is 0.5, so as you can see, it's going to be 0.5s all the way down for Wednesday. So now we're simply going to multiply these decimals together for each of the 8 scenarios, and mathematically you can see that these 2 are going to be equal, these 2 are going to be equal, these 2, and then these 2. So 0.4 times 0.3 is 0.12 times half of that, or 0.5 is 0.06, which I put the probability in percent, so that's times 100, that would be 6%. So each of these would be a 6% chance of happening. 0.4 times 0.47 is 0.28 times half of that is 0.14, or 14%. And if you notice, 6 and 14% add to 20%, and you have that twice, so that's 40%, and lo and behold, there's a 40% chance of rain on Monday. So if you look at this, these 4 are associated with this yes probability on Monday, so that makes sense that it's not coincidental that adds to 40%, and then these 4 will add to 60% to go along with the chance of no on Monday. So 0.6 times 0.3, that's 0.18 times half that is 0.09, 9%. And then finally, 0.6 times 0.7 is 0.42 times half that is 0.21, so 21%. And 9 and 21 make 30, and you have that twice, so that does make 60. So that all this totals 100%. So if you total up your percentages, you get 100. These are not rounded off; these are exact, so you should get 100 exactly. Sometimes if you add up percents, like you see on pie charts, you might get 99 or 101. It's probably because of rounding errors. You round off to the nearest percent or 1/10 of a percent or whatever. So now let's finally answer these 6 questions. What are the odds of rain on all 3 days? Well, there's only one such possibility. Yes, yes, yes. That's 6%. What are the odds that it will rain on exactly 2 days? Well, we have this scenario where it rains on Monday and Tuesday, but not Wednesday. So that's a 6% chance. And you add these all up. Also right here, it could rain on Monday and Wednesday. There's 14% chance of that happening. So 6 plus 14 so far gives us 20%. And then we have one other scenario where that happens, where it doesn't rain Monday, it rains Tuesday and Wednesday. And that's 9%. So 20 plus 9, that's 29%. And that will give us the following answer, the following question's answer. Rain on at least 2 days. Well, that's would be then on exactly 2 days or all 3 days. So you would add those 2 together to give you essentially a cumulative probability of rain on either 2 or 3 days. So there's a little bit better than 1/3 chance of that happening, 35%. These are in percent. Actually, I specified that over here. Okay, 35% so far. So now we're looking at it rain on exactly one day. So it's either going to rain just Monday, just Tuesday, or just Wednesday. Well, here, 14%. Here, that's another 9%. That's 23 so far. And the other one day with rain is at 21%. So you add 23 and 21, make 44. And just like in the above example, the odds of rain on at least one day, well, that's going to be 1, 2, or 3 days. So we had a cumulative probability of 35. Now we're going to add that to 44 to get the probability of rain on at least one day. And then finally, there's one possibility, one possible outcome of no rain on any day, and that's 21%. And that would make sense that rain on at least one day. So it either rains on at least one day, which is 79% chance, or it does not rain on any day during this entire period, which is 21%. So it's 1 minus the 0.79 to give you that, at least from a logistics perspective. Either it rains one of the 3 days, or 2 or 3, or it doesn't rain at all. So that makes sense that these two right here would add to 100. But anyway, this comes from adding the 35 and 44 to give you your cumulative probability. So this answers the 6 questions, and this shows the logic behind how you calculate these probabilities. So hopefully that makes sense and you learn a little something, have some fun, and there'll be more of these in the future, so stay tuned.